Now, one way to test the null hypothesis that there is no difference between drug C and D is to calculate the mean value of all the data from both the drugs. Is it possible to calculate the mean value of all the data from all the drugs? For example, the recovery times of all greens and recovery times of all these pink or red ones. You put all the data together, is it possible to calculate the mean? Yes, it is possible, and this is the line. So you calculate the distances between each observation like this. We know recovery time of this guy, this guy, this guy, this guy, this guy. What is the distance? Calculate the distance of each observation from the overall average. Now, in alternate hypothesis, what we do is we calculate the average of each groups, that is drug C people and drug D people who have been administered drug C and drug D, and then calculate from that average, not from the overall average, but individual averages of these groups, like this. Now, why are we doing this? Now you see the distance around the single mean represents the null hypothesis that there is no difference. There is only one mean because we take the whole data and put the mean. Represent the null hypothesis, there is no difference. The distances between two separate means represents the alternate hypothesis. This is the explanation of how the null and alternate hypotheses are actually calculated. Suppose if the distances around these two means are shorter than the distances around the single mean, then that suggests that using two mean to summarize the data makes more sense than using one. So we reject the null hypothesis because these two means are far apart. Alternatively, if the data looked like this, the distances from the single mean were not dramatically. Now that here also two means, but these two means are so close and almost same as the original average mean. Then that would suggest that the difference between the mean reflects only random things. Because of random things, somebody is exercised, that's why he recovered fast. Somebody is not exercised, that is why he's smoking guy, and that's why he recovered slowly and stuff like that. So we also know that one healthy person can shift the averages towards closer like this and become like is equivalent to the original mean. So in this case, we fail to reject the null hypothesis that it is the same thing realizing, means it has got the overfit of data, that is almost the same data. So we have only two groups of data and it is a hypothesis. Now, I want to bring in little heavier also. Suppose if we have three groups of alternate hypothesis, it becomes more interesting. So three or more groups, what happens is, null hypothesis is the same, right? There is no difference between C, D, and E. So like before, we can represent this overall average of all the three groups with a mean. Now we have choices for alternate hypothesis. What are the choices that we have for alternate hypothesis? One is we have C, D, and E are different from each other. That is one choice. Okay, all are different, right? There can be a few different choices, right? So in this case, we'll try to measure the distance between separate mean for each drug. Or alternate hypothesis could be C and D is same, but D is doing something else. Only E is different. So one of them is different from the other. Or two of them are same and one of them is different. And that two can be anything, right? C, D or D, E or C and E. So there can be a lot of alternatives possible. But why should we specify the alternative? Because we are testing whether we are going to accept or reject it in favor of one of the alternative hypotheses. So C, D are the same and E is doing its own thing, and C, D, E are different from each other. And then we do depending upon what we want. And finally, a decision whether to accept or fail to reject or fail to reject. We can end up making a different decision about the null hypothesis. And that is why it is important to clearly state which alternative hypothesis we want to use, because we either reject or fail to reject the null hypothesis in favor of that particular alternate hypothesis that we have chosen. C, D are doing the same thing, and one is this. We might say we rejected in favor of this alternate hypothesis. Okay. So there can be too many possibilities. So in summary, statistical test consists of three things. It needs data. So it needs null or primary hypothesis. Third, it needs alternate hypothesis. So we have to group the data. And then we said that we'll have alternate hypothesis, have the statistical test, and then end up in this computer.